This video is going to talk about imaginary numbers. Now, before we get to what an imaginary number is, we're just going to go through and solve a few equations. The first one's actually done for you in your handout, but I'm just going to go through and do it. So if we were going to solve x squared minus 25 equals 0, you could either factor this to x plus 5 and x minus 5 and make a t-chart and solve, but I'm going to go about it a different way just so it stays consistent with numbers 2 and 3. Okay, so what we can do is we can just add 25 to both sides of the equation, leaving us with x squared equals 25. And to get rid of a square, we're just going to take the square root. Now remember that when you have x squared, that means we can have a maximum of 2 answers that make this equation true. And in this case, we do wind up with 2 answers that make this equation true, positive 5 as well as negative 5. If you take positive 5 and plug it in, positive 5 squared is 25. And if you take negative 5 and plug it in, negative 5 squared is also 25. Okay, we're going to solve number 2 the same way. We're going to first add 8 to both sides of the equation, leaving us with x squared equals 8. And then this time when we take the square root, 8 isn't a perfect square, so we're going to just have to take it and write it in simplest radical form. So first thing, you don't want to forget your positive and negative. Again, we have 2 answers. And radical 8 breaks down into a radical 4 and a radical 2. And since the square root of 4 is 2, okay, this becomes 2 radical 2. Now, if you want to check, in your calculator, you can take a positive 2 radical 2 and replace for this x in the beginning, and you'll see the equation does check out. And you can also try plugging in the negative 2 radical 2 and replacing it in for x into the original equation, and you'll see that works as well. All right, so now what happens with number 3 is when we go to solve this equation, again, we're going to start it the same exact way, but this time when we go to take the square root, we're going to wind up with a negative under our radical. And we haven't, up until this point in math, we really haven't seen negatives underneath the radical. So this brings us into what we call an imaginary number. If we were to, let's not forget our plus and minus, if we were to break down the radical negative 9 into radical 9 and radical negative 1, now we already know the square root of 9 is 3, and we're now going to learn that the square root of negative 1 is equal to what we call the imaginary unit, I. Okay, so this is really important here. So what's going to happen is this radical negative 1 is going to become an I. So here our answer is x equals positive and negative 3i. Now if you want to pull out your calculator at this point, you can definitely check. So if you take 3i, the I button is actually right above the decimal. So in your calculator, if you hit 3 and then second decimal, you should see a 3i on your calculator. So if you want to check if positive 3i works in this equation, take 3i and square it and add 9, and you will see you do get 0. And then if you take negative 3i and square it, you will see that you will also get 0. All right, now if you look in the middle of your handout where it says, right underneath where it says I equals radical negative 1, you'll notice it says note I squared equals negative 1. And let's think about that. If I is equal to radical negative 1, if we took I and squared it, okay, so we're going to be squaring the radical negative 1, wouldn't a square and a square root just cancel each other off? So basically leaving us with I squared equals negative 1. So that's where that's coming from. Now there's a couple different powers of I that I really want you to have memorized, okay? Obviously anything to the first power is just equal to itself. So in addition to I being equal to radical negative 1, I is just equal to I. We just saw that I squared is equal to negative 1. Now if we wanted to find I cubed, all right, let me do this off to the side here. So I cubed, well, if you think about it, if you want to multiply 2 terms with the same base, all we do is add their exponents. So I cubed is really just equal to I squared times I to the first. All right, so we already know that I squared is equal to negative 1. Now we know I to the first is just equal to I. So if we multiply negative 1 times I, we get negative I. So I cubed is equal to negative I. All right, let's take a look at I to the fourth. If we look at I to the fourth, I guess I'll do that off to the side as well. I'll do that down here. So I to the fourth, let's say we can use I to the first times I to the third. I'm going to actually use I squared times I squared because, again, when you're multiplying two terms with the same base, we add the exponents. So since I squared is equal to negative 1 times negative 1 is really just positive 1. So I to the fourth is equal to positive 1. So these I'd like you to have memorized. And if for some reason you do forget one, luckily we have the I button in the calculator. So if you wanted to plug in I to the third power, okay, remember I is second decimal, and raise that to the third power, it'll give you negative I on your screen. Okay, so let's take a look at some examples on the bottom of the page. Now before we try to simplify, right, the directions say to simplify, I just want to make a note that we said that I is equal to radical negative 1. Okay, so that being said, let's simplify some of these expressions. All right, so in number 4, I'm going to take my 2 and bring it down. And then because we have a negative under the radical here, what I'm going to do is I'm going to break this up into, a radical positive 49 and a radical negative 1. Okay, so we can bring our 2 down, and since the square root of 49 is 7, this really means 2 times 7. And since the square root of negative 1 is I, I'm going to cross that off and make it an I. All right, so 2 times 7i would just be 14i. And one thing I want to point out, when you're simplifying, I mean, what we're doing is we're taking a positive expression and simplifying it, so we wind up with a positive answer. If you look back at number 3, the reason why we wound up with a positive and a negative 3i is because in number 3 we were solving for what values of x would make that equation true. And we had an x squared. X squared tells us we have a maximum of 2 answers. So the positive 3i as well as the negative 3i made that answer true. But in these examples here, you're just taking a radical and you're simplifying it. So if it's a positive, it's going to be a positive. If it's a negative, it's going to be a negative. Okay, let's take a look at number 5. So with number 5, I'm going to bring down the 2/3. And this time, again, we have a negative under our radical, but 18 is not a perfect square. So first thing I'm going to do is I'm going to really make 2 separate radicals for my 18. I want to come up with 2 numbers that multiply to 18 where one of them is a perfect square. So we have 9 times 2. But then I have to make a third radical over here to take into account this negative sign. So that would be negative 1. And it makes sense that I could break this up into these 3 terms because 9 times 2 times negative 1 is negative 18. All right, so let's bring down our 2/3. And then since the square root of 9 is 3, I'm just going to write times 3. I'm going to skip over this radical 2 for a minute. Let's basically get everything we can out of the radicals. This radical negative 1 is equal to I, so I'm going to cross this off and put my I out here. And then what I'm going to do is just bring down whatever I have left under the radical, so this radical 2. Okay, so to finish off, 2/3 times 3 is just 2. So this is when I multiply 2/3 times 3i, I'm going to get 2i, and I'll bring down the radical 2. Okay, from this point, I just want you to stop the video, and I'd like you to try number 6 and number 7 on your own. Then when you're done, you can hit play again and see how you did. All right, so I wrote out the answers here. I'm just going to quickly go through it. So with number 6, I brought down the negative 5. I broke this radical up into 36, 3, and negative 1. And since the square root of 36 is 6, and the square root of negative 1 is I rewrote that and brought down the radical 3. And then negative 5 times 6 is negative 30, so I get negative 30i radical 3. Okay, number 7, you had to individually simplify each term, and then you combine like terms at the end. So I brought the 1/6 down. The negative 48, I broke down into a 16, 3, and negative 1. And since the square root of 16 is 4, and since the square root of negative 1 is I brought that down, as well as the radical 3. And then 1/6 times 4i is really either 4/6i, or that simplifies to 2/3 I, and I brought down the radical 3 attached with it. Okay, now over here I brought down the 1/3, I broke down the radical negative 12 into radical 4, radical 3, and radical negative 1. And since rad 4 simplifies to 2, and rad negative 1 simplifies to I brought that down, along with the radical negative 3. And 1/3 times 2i is 2/3 I, and I brought down the radical 3. Now this time when you combine like terms, we have 2/3 I radical 3 plus another 2/3 I radical 3. So since 2/3 plus 2/3 is 4/3, we wind up with 4/3 I radical 3.